begin by saying that severing is a provocative term, right? And I used it for the purpose for it to be provocative. My publisher said that I couldn't use severing, I couldn't use sundering. When I had written a book that would be coming out, should be coming out next month, and they essentially persuaded me at this to end up calling the book Conserving Humanity at the Dawn of Post-Human Technology. There we go, it's a mouthful. Which seems very different, okay, from what I'm about to talk about. But they're related, because my interest comes from the standpoint that I believe that we do stand a good chance, right, of changing something about our human nature, okay, over the foreseeable future. And I'm not talking about 100 years from now. Right? And I'm looking at it from the standpoint that I think we can see that certain technologies have a velocity, right? And it's that velocity that I'm concerned about. And I come from a perspective that, and I'm not embarrassed to say, that 2.5 weeks ago was my 60th anniversary working in technology. Right? And in that course of time, I've done I've done a number of different things, okay, that have, I think, given me some insight, and perhaps many of you have that insight as well, as to how it is that technology can frame our own frame of reference. I've worked as a development engineer for about 20 years, and then I've been a patent lawyer for the next 40, and I've done a lot of work I took my master's in fine arts as well. So I've tried to combine these three things and to speak to what it is that's essential, okay, to us and that may change. And I'm talking about our essence, essentially. Right? And as I go through this, I want to keep coming back to that point, because we have to make sure that whatever it is that we're developing it with from the point of view that we don't want to change our being, our essence, to such an extent that, frankly, we'd be unrecognizable, okay, from the standpoint of where we even sit today, right? And I do think that that's possible. I'll try to make my argument in the following way. We're seeing at this point that there are anatomical intersections. We're seeing that electronics is beginning to, become a part, okay, of our anatomical makeup, mostly for prosthetic reasons. We have pacemakers and all of those kinds of things. We talked, we had this subject talked about this morning about the brain stimulations and all of that kind of technology. So the electronics is pretty clearly one that we can appreciate. We have the molecular one, which is pretty obvious. But I'm going to talk more about that in a somewhat unobvious way, okay, in a few minutes. But right now the molecular one is the obvious drugs that we ingest. Many of us take multiple pills every day, but there's even a more there's a different manifestation of how we're going to be using molecular technology in the anatomy. We're using computer technology, which again is like the pacemaker. It has a 486 or a computer in it. It can communicate. It's got an internet connection, so that when one walks into their doctor's office, they can basically be read from a distance by their doctor. The doctor can adjust their heart and whatnot. So this is all sort of old technology. The biological, we know that we're beginning to see that we're doing many more experiments and manifestations of gene technology, and the nanotechnology shouldn't speak for itself, but we're using nanotechnology, for instance, in the detection of cancers and the like. So all of this is sort of coming together in the anatomy. The question is, human extinction, all right, there were some headlines that I picked out. One of them was that human extinction is extremely likely. And now when I read that, it was sort of, again, a provocative headline. And I began to think about what does it mean when it says human extinction is extremely likely? Well, you could be talking about being hit by an asteroid, I guess, which is somewhat improbable. You can talk about nuclear war, I suppose. That's another possibility. But it may well be that we're not talking so much about human extinction as we're talking about creating, again, another another way in which we persist on the planet. Right? So we have these threats as life exists today that derive from these things that I just mentioned. But we also have the threat of genetic and digital technologies that will imbue psychological as anatomical enhancements in creating a notable departure from humans as they exist. And that's a mouthful. And when I began to think about the problem, I thought, what is it that, more than any other quality, right, that gives us what it is that we call our essence? And it's obviously this thing up here. And what is the main feature of this thing up here? It's our intelligence. It's the way in which we can sort of view the world, make sense out of the world, make sense out of our place in society, how we essentially exist. So I had some research objectives. One was the report on the progress to alter cognitive gene sets, and what kind of work is being done out there to essentially identify what are the IQ factors, okay? What are the factors that will alter our IQ? What are those gene sets that may be identified as altering our IQ, our intelligence? A report on the progress of the implantable bioengineered synthetic DNA digital constructs. These two things taken together are both capable in the future of working their way to improve, or if you want to think about it that way, to increase the level of our IQ. It may not be that we could identify all the gene sets that will, let's say, produce a 20 or 25% increase in IQ, but it may be that with implantable bioengineered synthetic DNA digital constructs, we might go that far and perhaps even farther, to the point where we become, I don't want to use the word cyborgs, okay, but something along the lines of where we are manifestations of not only our own, basic DNA or genome makeup with modification, but also we are a manifestation of things, okay, that have been implanted or things that we will have access to that will also aid in the construction of an individual, okay, with higher IQ. And then I considered what are the regulatory, to what extent do we have regulation and commercial control over this operation. I'm not sure I'll have time to talk about this, and then we can talk about this perhaps in the questioning part of this. So, the latest gene modification technology such as CRISPR targets candidates for genetic code alteration. You may know this. It was sort of news to me a couple of years ago when I sort of put my oar in the water. But there are genomic-wide association studies that are being performed. Right? And these are studies that involve hundreds of thousands of people whose DNA has been tested, like by companies 23andMe, for example, right? And other companies. Affirmetrics, I think, has a big part, plays a big part in this. And what the geneticists are doing is they're looking through this genomic-wide association data, and they're looking particularly for correlations, or they're making a further association for those individuals where they have the genome set and they're looking at their IQ scores, for instance. And they're beginning to see the correlation between the two and identify what genes may be associated with improvements or increases in IQ. Now, we know last year about this time, it was announced that this Chinese scientist had altered the gene set, right, of twins, the embryos for twins. It was a CCR5 gene that was altered for the purpose of reducing the possibility that, not the possibility, reducing to naught that these twins could ever get HIV virus, HIV, right? The AIDS virus. And it became apparent, okay, once the gene had been identified, and it does do that, scientists have known that for some time, that that gene is also implicated in one's intelligence factor. In other words, it has the capacity, the capability for altering one's intellect in a positive fashion. And it turns out that that's not the only gene. It turns out that over the course of the last 2 or 3 years, scientists have identified a sufficient number of genes, and I'm talking about on the order of 100 or more, that have some significance in altering our IQ. It turns out intelligence is polygenetic, which means that it's not just one gene, it's not 2 genes. There may be hundreds and perhaps maybe even thousands of genes, and they all have a small effect on our intellect. So right now they have identified sufficient numbers of genes that can probably improve IQ by about 5 points, which is significant. There's also technology that's out there, or at least is being discussed, that has to do with embryonic selection, okay, for increased IQ, and the manner in which they can recycle, okay, the embryos or the stem cells, okay, within the technology, in order to amplify essentially the number, the embryos that would be most likely affected, okay, in having a higher IQ. Right? This, you know, Bostrom, who was a philosopher and scientist, has come up with that scheme, all right, and it looks like it has some credibility. So this is what we're facing. Okay? We're facing a time when we've identified a sufficient number of genes so that we can do something with them. And question, you know, we might have regulation in this country not to alter the genes in such a way, okay, that it gets passed on. They call that germline editing. But there is a possibility that we could modify what's called a somatic line, okay, which doesn't get passed on to the next generation, but makes a smart kid, right, for you. And so this is what we're up against. So I'm going to actually skip over this one here. So we have major results. A detailed meta-analysis of intelligence involving 78,000 individuals determined, after looking at them, 336 associated SNPs in 18 genomic sites or loci, of which 15 had not been previously discovered. And this has only been in the past year. And overall, right now, we've accounted for about 5% of IQ genetically. The expression of IQ is polygenetic, as I mentioned before, so there are, you know, perhaps hundreds of these things. But my contention is that a small improvement in the overall IQ of a population or a demographic, let's say it goes up 5 or 10 points, could be considerable, at least in terms of who we are, right, as a society, or what a society represents. So now let me turn to a different.
1 minute.
What's that?
1 minute.
1 minute. Wow. All right.
More concerns.
Let me turn to another piece of the story. The other piece of the story is this. As engineers, we all know that it's very difficult to interface. I don't care whether you're interfacing you know, one electronic device to another. I mean, it's just, that's sometimes one of the harder things that we do in engineering. And it becomes even more difficult to interface into the anatomy. Right? So it took many years before they got the pacemaker to work well within the anatomy and stay there, you know, without creating havoc, wreaking havoc. But for the last 25 years, they've been working on synthetic DNA, okay, to modify cells. Right? So they've gotten to the point now where they have cells that will do A to D conversion, and it will do D to A conversion. It will act as switches. It will act as, you know, flip-flops. All of the things that we electrical engineers know about. But they're doing it at the cellular level. So it seems to me, at least, my instincts are that we can now, or they will be, taking these things and they will be more easily interfaced with the anatomy, or to the anatomy. Right? And there's a patent for anybody who wants to look at it, or I can send it to you. It's 9697-460, which speaks to this. It just came out a while back, and it's being held by the University of Boston. So, to sum it up, we've got this technology that I believe is moving at high velocity. There's going to be a convergence, by my way of thinking, and we have to begin to consider or think through what are the implications for our culture, for our own essence, because we will be